So let's start the webinar. Good morning, good afternoon, good evening, everyone. Thank you so much. A very warm welcome to all of you. And we would like to thank you so that you have taken time to join us today. My name is Priya Chakravarti, and I will be your host for this session today. We are excited to have you here. As we all know, today's webinar is on maximizing ROI for GPUaaS AI cloud providers and NVIDIA Cloud Partners. Let me give you the logistic details before we begin the webinar. If you have any questions, please feel free to drop them in the chat box or use the QA section. We will address them during our QA segment. The session is being recorded and the recording will be shared with you afterward. Let me introduce to our speaker today, Amar Kapadia. Amar Kapadia is a CEO and co-founder of Aarna Networks. Amar has over 20 years of experience in networking, storage, server, and IO technologies through marketing and engineering leadership position at Mirantis, Emulex, Philips, and HP. Amar is author of 3 books, ONF Demystified, Understanding OpenFV, and OpenStack Object Storage Essentials. He holds Masters of Science in Electrical Engineering degree from the University of California. He lives in San Jose. I welcome you, Amar. So let us dive in today's session. I will hand over it to Amar to take it forward. Over to you, Amar.
Thanks, Priya. Welcome, everyone. So as Priya said, today's focus is going to be on the financial side. The web is meant for GPU as a service, AI cloud providers / NCPs, NVIDIA Cloud Partners. We can also call them neo clouds, several names. So before we get going, we are hearing loud and clear from our customers. We recently interviewed 6 of them. And the message from them is very clear. They need to increase their utilization and combat GPU price declines. So basically, our customers are saying that, which essentially are your peers. One is a US NCP. It's a small NCP. And they're using our GPU cloud management software to register capacity with our marketplace. We have another one in US and Canada growing to 3,000 GPUs using our software. They're using us for our dynamic multi-tenancy and billing integration. We have one in Europe who's using the GPU cloud management software for dynamic multi-tenancy on-demand instances. We have a US edge-based NCP. They're focused on edge GPUs. And they're using us for multi-tenancy and also for workload orchestration, dynamic workload orchestration. One in APAC, similar, and then one in India, also very similar. So what we are finding with our customers is that most NCPs start with static allocation of their GPU resources for large training customers. So this picture shows that the environment is statically allocated using manual workflows for provisioning, billing, monitoring, and scaling. And each instance is given to a customer for a long period of time, 1 year, 2 year, 3 year. And that works great. Initially, that's the right way to do it. It works perfectly. But the problem is that we have an annual GPU refresh cycle. That means older GPUs are not attractive for training. So when the term expires, the 1 year, if it's a 3-year term, then nothing to worry about. But if it's a less than that, if it's a 1-year term, potentially a 2-year term, then once that term ends, the customer is most likely to require new GPUs. So today, if you have a training customer, they are unlikely to request H100s. They're going to ask for H200s or even Blackwells. So that means that the GPUs that just got returned back to the pool by a customer who was using them for, say, 1 year, 2 years, are not going to be used for training. So either they have to be used for something else or they're going to sit there underutilized. So this results in both price declines and declining utilization. So you might say, what's the evidence? Well, the evidence is right here. So in June of 2024, 1 year price for H100 was between $2.20 to $2.50 if you committed for 1 year. Today, we are seeing them in the 160 to 180 range. So, I mean, that's a significant price decline. Also, in June of 2024, H100 availability was tight. There was GPU was supply was constrained, and people were desperate to find GPUs. Now H100 availability is plentiful. So this we were not able to quantify. We were not able to quantify, for example, how many GPUs are underutilized, but anecdotally, we can tell you that all of our customers have H100s. You want H100s, you'll get H100s. So meaning both the price is declining and the utilization is declining. So what can you do? So there is a solution. The solution is to offer on-demand instances and PaaS features. So on-demand instances can increase the utilization because now you are addressing users other than just training. You can go after customers who want to do inferencing. You can go after customers who want to do fine-tuning, computer vision, small language model training, distilling, so on and so forth. So what we have seen is that the price increase because of on-demand can be as much as 30 to 50%. So if you're charging $1 per GPU hour for reserved instances, you can charge $1.30 to $1.50 for on-demand instances. So there you have it. You are able to increase the utilization by addressing more use cases, and you are able to increase the average selling price or the ASP by 30 to 50%. So this is a great start. But that's not, we can't stop there. You can also add PaaS features. These are LLM as a service, job submission, if people are doing fine-tuning or deep learning training, etc. And through these two, you can increase the utilization again because now more use cases are getting unlocked, and you can also improve the average selling price by about 100%. So if you look at companies, neoclouds that offer LLM as a service, they're effectively able to about 2x of what a reserved instance might cost. Now, sometimes the modality is changed. So they might charge you on a tokens per second instead of GPU per hour. But ultimately, if you work everything out, it's about a 2x improvement in ASP. So this is great. So you're probably thinking, wow, let's do this. Why? This seems like a great solution. But before we go there, you might be thinking, is there a quantitative way to model this improvement? And yes, there is. We have developed a GPU ROI calculator, and I'm going to give you a demo of that calculator right now. Oh, sorry, one more quick thing. So we will consider 3 scenarios in the calculator. We will consider a static only scenario and see what the internal rate of return and other financial metrics are for that static only use case. Then we will look at a static use case with additional capacity offered as on demand. So at one point, we considered the scenario where maybe everything is offered on demand. But that use case, that scenario is not realistic. So what we did is we changed it. So you can keep offering most of your capacity as static to your training customers or long-term contracts. But the additional underutilized capacity, you make it available as on demand. And the third scenario is offering PaaS on top. So PaaS can be offered both to on-demand customers and to static. There is nothing specific about a PaaS that makes it suitable only for on-demand customers. So PaaS is going to be offered to all customers. So if we model all this out, what do we get? So let's take a look. So we have an NCP pro forma ROI calculator that's available, and at the end of the webinar, we will give you a link so you can go download it. And it has multiple tabs. So it has a cover page, which we will take a look at in a second. We have an assumptions tab, and then we have the three scenarios that I mentioned. We have the static scenario, we have the on-demand, static plus on-demand scenario, and then we have the static plus on-demand plus PaaS scenario. So let's look at what the assumptions are. So we have deliberately kept the calculator quite simple. So I think we've all seen calculators where there are multiple tabs, there are so many calculations going on that by the time you get the result, you really have no idea of how the result is connected to your assumptions. So this is deliberately a very simple calculator. If you're a CFO or someone with a financial MBA type background, you might find this maybe not complete enough, but the idea is to get high level modeling on based on your assumptions. So let's look at the number of GPUs. So let's say 1024 GPUs, capex per GPU, roughly 30,000, but you can change it. Let's make it 32,000. Interest rate, let's make it 8.7%. Loan to capital percentage, let's make it 75%. Loan term, we can say 4 years, the assumption is 3 to 5 years. The reserved price in year one. So this is a huge variable. If you had started with H100s in the beginning of say 2023, the price you could have started with would have been much higher. But if you started in say Q4 of 2024, you would have started with something like $2.20. So anyway, this is changeable and this is not only for H100s, it can be used for H200s, it can be used for B200s. So just put whatever price you're going to start with. So let's say we are starting with H200s, and let's just say, I'm just making it up, $2.40. The price degradation year over year for reserved instances, let's say 20%. The instance premium for on-demand. So this is where we said if a static or a reserved instance is $1, how much will an on-demand be? So it's let's say 35% premium, so $1.35. PaaS, we are saying 2x, 100% premium. OpEx per GPU per year. OpEx includes everything. It includes, power, cooling, people, any software licenses per year, subscription. So you can add all of this up. Roughly, it's about 3,500. Let's make it 3,600 just for kicks. OpEx growth year over year. Let's make it 5%. And these are some assumptions that will be very customized to your situation. How much is the unused capacity? How much is the underutilization by year? So what we are assuming is, let's say year one is 5%, year two, 12%, year three, 18%, year four, 25%. And we said 4-year life. So, frankly, year five doesn't matter. It can be anything. Some financial metrics, NPV discount rate, cost of equity, tax rate, particular geography or country. Life of the GPU, this can be 3 to 5 years. And then, like I said, we are offering PaaS to all customers, static and on demand. So how many of them will actually end up using PaaS? So you can model this, you can say 25%, let's say. 25% of all customers will use our PaaS features. So this is job submission, model as a service. So there are some items that are calculated on this page because of the assumptions we put in. Revenue per GPU per hour, exclusive of utilization, inclusive of utilization, on-demand PaaS. some other utilization numbers, OpEx growth over time. And then we have the specific pages that calculate the financials for each scenario. So this is for the static scenario. You have revenue, COGS, OpEx, interest, tax, so on and so forth. And at the end, you have some financial metrics that get calculated. Same for on-demand. And then this is, by the way, this is, even though it says on-demand, the on-demand is being applied only to underutilized GPUs. So it's still a mix of static plus on-demand. Not everything is on-demand, obviously. This is static plus on-demand plus PaaS, interest schedule. And on the cover page, you get a nice summary. So the three scenarios are defined. So static is very clear. On-demand, only spare capacity is allocated on demand. The rest is all static. And then this is model serving, job submission, etc., applied to the entire environment. So you see the financials. It's about a $8 million investment just for the hardware, etc. Multiple on investment capital. The ROI effectively is, not that great for static only, but starts to improve as you go to on-demand and PaaS, weighted average capital cost, the actual return you're getting on the investment, net present value, and then internal rate of return. So again, on the static, it's not that great, about 10%. But then on the static plus on demand, you see 30%, 32%. And on the static plus on demand plus PaaS, it's improved significantly to 136%. And then you see some nice graphs. This just shows you the revenue per unit assumption, how the revenue is going down over time. And you see the internal rate of return and the multiple on invested capital, so MOIC. So you see the IRR 10, 32, 136, and the multiple going from 1.08, 1.52 to 4.16. So you might be saying, you know what, this is great. I'm in agreement. If I can add these capabilities, my returns improve. How do I get there? So the exact problem is being solved by our product, aarna.ml GPU cloud management software. We provide on-demand multi-tenancy and platform as a service features. And as I mentioned, for us, it doesn't matter. We can take the entire environment and make it on demand, or we can just more logically, we can just take the subset that's underutilized and offer it as on demand. The rest can still be static. For us, it makes no difference. So the product is shown on the diagram on the left. So let's walk through it. So at the bottom, you have hardware. So you have NVIDIA GX, MGX. This only shows the compute, but obviously you have the networking fabric like Spectrum-X, InfiniBand. You have storage coming from vendors such as VAST, Veka, and DDN. Above that, you have the hardware provisioning layer, like base command manager from NVIDIA, or some customers prefer to just use Redfish and have us provision the hardware directly through Redfish. So either of that is fine. Our product is split up into two parts, Infra Manager, and then Platform Manager with the self-service user interface. The Infra Manager starts with the admin console. So this is available to the NCP admin. The NCP admin uses this console to discover or onboard the hardware. They use it to observe the hardware, look at faults, create tenants, create flavors or SKUs, and create the tenants. So all of that can be done through the admin console. Above that, we have the tenant. The tenant is split up into two personas: the tenant admin, who owns the entire organization, creates tenant users, manages quotas, looks at the billing, etc. And then you have the tenant user. The tenant user goes through the top interface. So they can create GPU instances explicitly. So if they know that I want 8 GPUs or so many vCPUs, so much memory, so much storage, they can go and create instances explicitly. They can be bare metal instances, virtual machine instances, or Kubernetes instances with GPUs. These instances are created with hard isolation. So very strict isolation that lends itself to the highest level of security. So we use the NVIDIA reference architecture recommended techniques to provide Ethernet, InfiniBand, CPU, GPU storage isolation. So today we are not doing a technical webinar, so we will not go through all of this, but we do have a reference architecture document. It's an extensive document that explains this in a lot of detail. So if you're curious about how we do the multi-tenancy, what do we mean by multi-tenancy, I would encourage you to look at that reference architecture document. So we also have two other ways where users can interact with the GPUs. If they know what resources they want, they can explicitly create them. But a lot of times, users, data scientists don't know how many GPUs they want. They might have a job that they want to submit, or they might have a model, a Llama model or a DeepSeek model that they want to spin up, but they're not sure about the number of GPUs. And also the number of GPUs can change over time. If it's a model that they're serving up, then the number of tokens per second can vary. And the underlying hardware has to scale out or scale in depending on the number of tokens per second. So we have two serverless ways, modalities where users can interact with the GPUs or request resources. Model serving, so they can point to a Hugging Face model or to a NIM from NVIDIA, have the model spun up with a dedicated endpoint, and then the underlying hardware scales depending on the load on the LLM. We also have a job submission modality. So once a job is submitted, the hardware is provisioned automatically, the checkpointing, result saving, and ultimately termination of the GPU resources is all done automatically. These are first-party interfaces. We also have third-party apps that we can support: Slurm, Run AI, and a variety of others. This user interface is obviously customizable because every NCP wants to have a unique look and feel. They want to have a interface that represents them and represents the catalog of third-party applications that they choose and they partner with. So clearly, for that reason, the self-service interface has to be customizable for each NCP, and that's something we offer. So that's our product in a nutshell. We also have a billing interface. We have done full integration with one cloud billing provider called Monetize 360. So if you are a greenfield NCP and you don't have cloud billing, we already have a full integration. But if you have a separate billing provider, that's fine too. It's easy to integrate. We have user management and role-based access control. And that constitutes the aarna.ml GPU cloud management software product. I think we covered everything on the right already. So that is the conclusion of our webinar today. And we'd like to open it up for questions. And just before we go to questions, there is a link to the GPU calculator, GPU ROI calculator at the end, and you have my email address. So feel free to contact me or anybody else on the team. And also please try out the GPU calculator, and we would love to get your feedback on how you found the GPU calculator. So thank you, and we'll open it up to Q&A.
Yeah. Thank you so much, Amar. Yeah, let's give few seconds. Yeah, so we got our first question. What is the average GPU utilization measure you have considered only for infra and for PaaS?
Yeah, so I'm seeing the what's the I'm looking at the two questions. What's the general OpEx ratio you are running? Is a 95% utilization high to start? I think it depends. I think it's a case by case. We are finding a wide variety of NCPs. Some NCPs only do, for example, 3-year contracts. So their utilization is going to be very high, maybe even 100%. But then other NCPs don't do that. Some are actually very open to shorter term contracts, so their utilization will be lower. So I completely agree. I think it could be 95%, it could be 90. I think that's an assumption that each NCP has to play around with.
Yeah.
And then the second one, have we evidence to support the uplift in revenue for on-demand and PaaS? Yes, I think if you look at any of the GPU as a service cloud providers, and there are so many, the average uplift for on-demand is about 30 to 50%. And PaaS, we have looked at people like Together.ai and others that offer model as a service, etc. And we can see evidence that it's about a 2x uplift.
Okay, thank you so much. And Milind, you can also just see in case I missed something. Okay, I got one more question. Can you quote some NCPs or neo cloud providers who actually got benefited from this strategy?
Yes, yes. So the 6 customers I showed have benefited. For today's webinar, we were not able to show their logos and names. We still have to get permissions, and we are going through that process. But the 6 customers that we showed have used our software exactly for this reason, is to be able to offer the unused capacity on an on-demand basis and to be able to add PaaS features.
Okay.
Okay, I see one more question here. So Amar, it is what commercial models do you have with your partners? It further states, I think it was also be good to outline your support and partner models that helps organizations getting started,
So
plus
we
the
have,
white label offering.
oh
Yeah.
yeah. That sounds good. So um, we have a very streamlined way of getting started. So if anybody wants to try this out, um, we have 2 models. We have a software model and a SaaS model. So the software model is for those who are willing to take our software, implement it on-prem, and get going. And that's a very traditional license and support subscription model. There are variations possible on that model, but basically it's a traditional software model. And the SaaS model is more of a pay as you go. So you pay per GPU hour, and you pay only for the GPU hours that actually get sold. So if you don't sell, we don't charge. Is kind of how SaaS works. Now there's a POC that we can do to get started. There is one POC we can do on a digital twin on a product called NVIDIA Air. So there is no hardware required. You can try the software out in a completely digital twin simulated environment. That takes about a week. Then a POC on a real hardware takes about a couple of weeks. And then the implementation takes about 4 to 8 weeks. So literally in 1 quarter from start to finish, we can be live. And I think a very good point on white label. So when I talked about customizing the user interface, we can customize the logo, we can customize the color scheme, we can customize the tabs, we can customize what PaaS partners you want to add. So it's completely the software interface or the SaaS interface is completely white labeled to make it look like your interface that represents you.
Thank you. Thank you. Are there any additional levers for optimizing the ROI on the traditional static GPU rentals? Does Aarna provide any solution in that regard?
There are some methods that you can use on the traditional static model. The number of levers you have are more limited because the utilization is frankly dependent on the contracts, how long-term your contracts are, and the costs are largely fixed. But there are ways to, for example, cut your OpEx. If you're doing everything completely manually, then your OpEx is high and the error rate can be higher also because humans make mistakes and might make a mistake on provisioning or deprovisioning. So that actually can be fully automated by our software as well. So you don't have to use on demand to take advantage of our software. Even if you're doing static allocation, our software can fully automate that. So that makes it possible to cut your OpEx and improve your ROI. The other big lever is fault management. So if you are able to manage your faults correctly, and everybody has seen the Meta paper, right? The Facebook paper on the number of faults they saw over a 50-day period using 16,000 GPUs. They documented all the faults they saw, what frequency, how many were there. So and I'm sure everybody's seen that. So if you are able to manage your faults properly, you will hit your SLA on availability uptime. So you won't have any penalties, and your customer experience will be better and your OpEx will be lower. So fault management is another way you can reduce your cost. And we have full NetQ integration to look at the faults on the networking side and also to address them. In many cases, we can address them automatically. So I would say if you're static only environment, there are ways to improve the ROI, but the levers are limited in scope. But please talk to us. We can help you even there.
Thank you. Milind, you were saying something?
No, Priya, I think you covered that question.
Okay. Yeah, so thank you, audience. There are a lot of queries I'm getting, so I'm just replying to them on our email ID. So we will close the webinar here due to time constraint. And thank you everyone once again for joining the webinar. Thank you, Amar, for the wonderful session. Please email it to us and we would love to have further conversation with you all. See you all soon. Good night and good day. Bye-bye.
Thank you.
Thank you, Amar. Bye.